Hello, dear students. This is your physics teacher Ashish Sharma from True Education Point, and this is the second lecture on second unit current electricity. In last lecture, we discussed about drift velocity and derived the relation Vd is equal to E tau by m. In this lecture, we are going to explore the topic little more, and we will further continue the syllabus of class 12th physics. So here is a new term mobility, which we represent by symbol mu. It is defined as magnitude of drift velocity per unit electric field. So we can write it mathematically like Vd is directly proportional to E, and when we remove the directly proportional sign, mu comes in as a constant. So mu becomes Vd divided by E. As you know, you have already derived the relation Vd is equal to E tau by m. If you will put the value of Vd in this relation, you get another relation of mu, that is E tau by m, where E is the charge of electron, tau is the average time period of collision of carrier, and m is the mass of charge carrier, that is electron. Using this formula, we can calculate the mobility of electrons and holes separately also. If we put the value of relaxation time for electrons and mass of electrons, this will give us mobility of electrons. If we put the relaxation time for holes and mass of hole, that is proton, then we'll get the mobility of holes in the conductor. I would like to tell you that mobility of electrons is generally greater than mobility of holes. That's why the devices which are based on electrons are much faster than devices which are based on holes. So p-type and n-type, you will study them later in your 12th unit in semiconductor chapter. Total current in a conductor is sum of the current due to electrons as well as holes. SI unit of mobility is meter square per second per volt, or you can write meter per second per Newton Coulomb. The next topic is relation between current and drift velocity. Dear students, consider a conductor as shown in figure, which is connected to a battery having voltage V and current I is flowing. If current I is flowing in this metallic conductor, then electrons must be moving in the opposite direction as shown in the diagram. Let us consider number density of electrons in this conductor B, n electrons per unit volume. And as you can see, this conductor is of cylindrical shape. The volume of conductor is A into L. If we will multiply the volume of conductor with the number density of electrons, we will get total number of electrons in this conductor. And if we multiply it with charge on electron, we will get the total charge present in the conductor, that is equal to NeLA. Now, the time taken by charge to cross the conductor, as the length of the conductor is L and average velocity of electrons is Vd. So, time that electrons will take in crossing the conductor is L divided by Vd. Now, the two values from these two equations, the first equation in which we calculated charge NeLA and second equation in which we calculated time L by Vd, if we'll put these two values in the relation I is equal to Q by T, then we'll get the relation I is equal to A Ne Vd, which is your desired relation between current and drift velocity. It is very important relation, and it appears almost in every board exam, and this question comes in 3 marks. So please pay more attention and revise it properly by writing. The next is Ohm's law, which you have been studying since class 8th and you have revised it in class 10th. Here I am in class 12th again defining this for you. Physical conditions remaining constant, current flowing in a conductor is directly proportional to the potential difference across its ends. Physical conditions here represents temperature. If temperature variation is not there, resistance of a conductor remains constant. Mathematically, we can write voltage is directly proportional to current and V is equal to Ri. This is your equation of Ohm's law. If you will plot a graph between current and voltage, you will always get a straight line which is representing resistance is constant. If you will take tangent theta of the inclination of graph, that is known as slope of graph, then it will give you resistance. So your R is equal to tangent theta. So you can always find out the resistance if the angle of the VI graph is given. Here is one new topic in class 12th, that is microscopic form of Ohm's law. So the already derived relation, we can use those relations for finding a new value of rho, and that is known as microscopic form of Ohm's law. So first relation is Vd is equal to E tau by m, which we have already derived in previous lecture, and I is equal to A Vd, which we have derived in this relation. तो अगर हम Vd की वैल्यू E tau by m यहाँ से इस I इज इक्वल टू ए एन ई वी डी में पुट कर देंगे तो ये हमारे पास रिलेशन बन जाएगा ए एन ई स्क्वायर कैपिटल ई टो डिवाइड बाय एम। सेकेंड स्टेप, हमें पता है कि E इज इक्वल टू वी बाई एल है, ये रिलेशन भी हमने फर्स्ट यूनिट में पढ़ा है चैप्टर 1C में, द रिलेशन बिटवीन इलेक्ट्रिक फील्ड एंड वोल्टेज। तो E की वैल्यू हम जब V बाई एल पुट करेंगे तो ये हमारे पास रिलेशन आ जाएगा I इज इक्वल टू ए एन ई स्क्वायर वी टो डिवाइड बाई एल इंटू एम। इस रिलेशन को जब आप कंपेयर करोगे आपके ओम्स लॉ से, दैट इज I इज इक्वल टू वी बाई आर, तो आप देखोगे कि जो R की वैल्यू है आपकी, क्योंकि V हमारा सेम है यहाँ पे और I भी हमारा सेम है, तो R की जो वैल्यू है वो हमारे पास आ जाएगी एम एल डिवाइड बाई ए एन ई स्क्वायर टो। अब आपको 10th क्लास में आपने पढ़ा है कि R इज इक्वल टू रो एल ओवर ए होता है, तो R को अगर हमने रो एल ओवर ए लिखा और इसको हमने एम एल बाई ए एन ई स्क्वायर टो से कंपेयर किया तो हमारा L से L कैंसिल हो गया और A से A कैंसिल हो गया, तो हमारे पास रेसिस्टिविटी का फार्मूला आ गया एम बाई एन ई स्क्वायर टो। So dear students, this is also known as microscopic form of Ohm's law. One more point I would like to add, that sigma is known as conductivity of a conductor and it is defined as 1 by rho. So sigma is equal to n e square tau divided by m. So these are very important relations. You must go through them and revise them in writing, otherwise you are not going to reproduce them in your final exam. Revise them properly. We'll see you in next lecture. Till then, take care, stay safe. This is your physics teacher Ashish Sharma. Thank you.